Hello, my name is Robert Smith, and I'm with New River Community College. And today we are looking at indoor pollution. Indoor pollution is another topic of chemistry of the atmosphere. And one of the common ones associated with indoor pollution is radon pollution. Radon 222 is an intermediate isotope in the radioactive decay of uranium 238. Small deposits of uranium 238 throughout the country, throughout the world, can lead to radon 222 occurring in basements of houses. And typically, the accumulation of them is the result of poor ventilation in the basements of houses. So, what we can do is we can look at we can predict um, how long some radon might last in your house. So if you had 2 grams of radon in your basement, how much would be left after 20 half-lives, which would be 72 days. So so that's about 2.5 months. So if you had 2 grams of it, how much would be there after about 2.5 months? And there are a couple ways that you can address it. The formal way of doing it is by saying that you're solving for the reaction constant by taking the natural log of 2 over the T1 half, which would be 3.8 days, and then using that to plug into our equation where natural log of A over A naught is equal to negative KT. And T would be you would calculate how much time is 20 half-lives, and which 72 days, and then you would take your negative constant that you solve for here and plug both of those in, and then what you would do is you would add the natural log of the original, which you could take to be 2 grams. Now, that's one way of doing it. Perhaps a more efficient way of doing it would be to say that you're going to, every time you hit 1 half-life, you've cut the total quantity by half. So you could say that after 1 half-life, you could have your final mass is equal to your initial mass times 1/2. Okay. Similarly, you could do for 20 half-lives, our final mass is equal to our initial mass times 1/2 to the 20th power, because this one is the equivalent of saying 1/2 to the first power. So this is 1/2 to the 20th power. And if you do it this way, then it's a little simpler. So we say our final mass is equal to 2.0 grams times 1/2 to the 20th power. So you take 1/2, raise it to the 20th power, and then multiply by 2. And you end up with 1.9 times 10 to the minus 6 grams, or 1.9 micrograms. And that's one way of doing it. If you did it the original way, you'd come up to the same result, but this is just a little faster, a little easier method of calculating this result.